Very good morning to all of you. Today I want to start experiment number 22. Title of experiment number 22 is Filter sand analysis and determine effective size and coefficient of uniformity of the given samples. So this is the title of this experiment number 22. So based on this title and based on these subjects, so there are 4 course outcomes are prepared. One is acquire capability to conduct experiments and estimate the concentration of different parameters. Second one, compare the result with standards and discussed based on the purpose of analysis. And third course outcome is determine type of treatment, degree of treatment for water and wastewater. Next, identify the parameter to be analyzed for the student project work in environmental stream. Now title of subject is Environmental Engineering Laboratory and the subject code is 18CVL67. This comes in 6th semester of civil engineering departments. Now see, these are the apparatus and equipments are used to execute experiments. Okay, but in this experiment there are different sieves are there and as well as weighing balance are used. Okay, remember these apparatus we are continuously used in the required experiments. See, basic concept of these experiments. The size of filter media is specified by the term effective size D10. It can be defined as the size of the sieve in mm through which 10% of the sample of sand by weight will pass. That is the meaning of D10. The selection of the correct effective size is very important because too smaller size will lead to very frequent clogging of filters and will give very low filtration rates. Similarly, too large size will permit the suspended particles and bacteria to pass through it without being removed. The uniformity in size or degree of variations in size of particles is measured and expressed by the term uniformity coefficient. It is calculated D60 by D10 may be defined as the ratio of the sieve size in mm through which 60% of the sample of sand will pass to the effective size of sand. So this is the concept and background of these experiments. Okay. Apparatus. Which are the apparatus are required here? Here, first a set of sieves of IS size 100 mm, 80 mm, 20 mm and 4.75 mm are used. And second set of IS sieves of size 2.8 mm, 2.36 mm, 1.18 mm, 600 micron, 425 micron, 300 micron, 150 micron, 90 micron, 75 micron, lid and pan. Then mechanical sieve shaker is required. Next, stiff brush is required. Balance and weights are required. So these are the apparatus are required to execute this experiment. Procedure. Now take suitable quantity of given sample of sand that is oven dried. Clean the set of sieves and pan with wire brush. Then next, sieve the given sand sample through IS sieves of set of 4.75 mm, 2.8 mm, 2.36 mm, 1.18 mm, 600 micron, 425 micron, 300 micron, 150 micron, 90 micron, 75 micron with pan at bottom. Means now you arrange these order sieves and fill the sample and do the sieves by shaking. Okay, that is next step is sieve the material by mechanical sieve shaker or manually up to 10 to 15 minutes. Then after 15 minutes, weigh the material retained on each sieve nearest to 1 grams. weigh the material written on each sieve nearest to 1 grams. Then after taking the weights, now plot the graph of semilog sheets as diameter of particle in mm as x-axis and percentage finer on y-axis. So then find diameter of particle with respect to 60%, 30% and 10%. Substitute these values in the respective formula to get Cu and Cc. Now see the results. The uniformity coefficient of given sample Cu is in number. The coefficient of curvature of given sample, that is Cc, in number, and effective size of given sample you write based on the graphs. Okay. So then write the comment here. From the experiment conducted for filter sand analysis, the effective size of given sample of sand, that is D10, is found to be X number and Cu is found to be X number. The effective size of the sand used for slow sand filter varies from 0.2 to 0.3 and Cu from 2 to 3. And the effective size of sand from rapid sand filters varies from 0.3 to 0.6 and Cu varies from 1.2 to 1.7. The effective size of sand for immediate sand filter varies from 0.2 to 0.5 and Cu varies from 2 to 5. So based on these conditions, you write the which type of sand filter is there. Hence the given sample of sand can be used for slow sand filter and intermediate sand filter based on Cc and Cu. Okay. So now this is the observation and calculations amongst these tables. So this table is nothing but a sieve analysis. You have seen and you have understood and you have conducted in earlier labs, that is BMT lab, okay, concrete lab, etc. You have determines this sieve analysis experiment. Same table we are repeated here. So column number 1 is sieve size, we are writing in mm as well as in micron, and second column mass of each empty sieve in grams you write in this column. In column third, mass of sand retained on each sieve in grams you write in column number 3, and column number 4 is cumulative mass of sand retained in grams. So you complete the column 4 with respect to column 3. So then percentage cumulative of sand retained you write, you calculate in column 5, that is cumulative mass of sand retained divided by original sample taken into 100. We are getting the value in 5th column. So then 6th column is percentage finer passing, that is 100 minus 5th column you deduct. So we are getting percentage finer. So after completion of this table, now plot the graph. So based on percentage finer on y-axis and sieve size in mm along x-axis, then you plot the graph. Then you calculate Cc equal to D30 square by D10 into D60 formula. Substitute the value here. We are getting Cc in numbers. Similarly, Cu you calculate based on this formula, D60 by D10, where D60 is diameter of sand particle at 60% finer, D30 is diameter of sand particle at 30% finer, and D10 is diameter of sand particle at 10% finer. So this is the meaning, and above is formula. Substitute the value in this formula. Based on Cc and Cu you classify which type of filter sand is required. Next, these are the references or reference for these experiments. Okay, thank you one and all. Next class means next experiment I will be continue in next class.